Hello and welcome to our course on daylighting. The importance of daylighting cannot be emphasized enough, and in this particular presentation we are going to talk about what is daylighting, why is it important, and what role it plays in our lives. Light from sun has been the source of all life on this planet. This light comes in forms of electromagnetic radiation and has been the life-giving force since then. Since the beginning of time, it has shaped how life has evolved. And now, ever since humans have started construction, started living in buildings and in structures designed by them, light and daylight has been the most critical factor that has shaped the form of these buildings. It's important because it has an aesthetic function. Light, shadow, color, views shape our appreciation of the universe, of things around us. It's important because it has a psychological and biological benefits. And of course, daylight is one of the most sustainable form of providing lighting in space. So, although we understand all of this intuitively, a lot of quantitative surveys have been done that have looked at users' responses and how people look at daylight in their lives and its importance in their performance. So, the feeling of well-being, comfort, the connectivity with the outdoors and its direct linkages with productivity have been now very well documented. There's also been a lot of studies that have looked at the energy savings aspects and the linkage that allows us to get daylighting into the building so that we can switch off artificial light and therefore save on energy. A recent study by scientists in universities, actually this one is particular from Northwestern University of Illinois at Urbana-Champaign, investigated the effect of daylighting and exposure on the health of a group of office workers. And it said that it found out that those who received exposure to more daylight through windows or any other means slept on an average 46 minutes more, they were more productive, and they were more focused in their working and awake hours. So, they clearly showed more energy, vitality and productivity during those hours. Daylighting has this impact on the perception of space, which is quite distinct from artificial lighting. Daylighting also connects with the architectural intent. So, when you look at design, when you look at shape of an object, the look and feel, whether it is dark, light, and the appreciation of form is directly linked to daylight. And the fact that daylight is dynamic, it means that these perceptions can evolve and change. They do change during the day, during the course of the year, during different seasons. So, it creates a dynamic effect which artificial light rarely is able to match even with all the controls. So, you see this in forms and shapes of buildings around you, in the appreciation of spaces and how they change over the course of the day. I did talk about the effect of daylight in energy savings because wherever you have natural daylight, you can either manually or very often through automatic controls reduce the energy used in artificial lighting. This also directly reduces the amount of heat that is generated in the space, which can therefore result in lower demand for cooling, especially in climates that are dominated by cooling demand. The objective of daylighting design or a good daylighting design should be to provide enough illuminance without glare. So, this is the fundamental rule of daylighting, that if the lighting level is beyond a threshold, then it will become a problem for the viewer, and they would tend to either put down their blinds or move away so that the glare doesn't interfere. So, glare-free illuminance while providing overall visual comfort, improved aesthetics, overall productivity, health, and reduction of electric lighting energy use. These are the driving principles for getting daylight into a space. Very often this is not done because just providing a window without shade, for example, is the easiest option for most designs, or I would say most developers, because the addition of a system of providing daylighting deeper into the space can often mean more design time and also more cost in terms of a shading device. So, very often you'll see that these things are not very commonly done. Secondly, there is a problem with technologies where the integration of daylighting and with different facade systems or with different lighting technologies is not very well understood. Finally, sometimes because of the orientation of the building or where the site is located, where it cannot have the optimum orientation, or there is another obstruction that prevents daylighting, can also be a problem. Sometimes it's seen as a design risk, because if you don't do daylighting correctly, then it will often create problems of glare or of very high contrast ratios in the field of vision, even if it's not directly glare off of a desk or a screen. And this inconsistency in daylight as it changes through the day or the course of the day, if it's not well understood, creates a sense of apprehension in many designers. So, they tend to rely more on artificial lighting to provide that overall uniform lighting and without resorting to daylight. So, all of these problems are easily surmountable, they are addressable, and there are many projects and case studies which we will see in this course, which will demonstrate to you that it's fairly easy to overcome these challenges. So, one major concern that we see is with the concept of understanding of daylighting. From a pure physical sense, sun is the source of daylight, it's also the source of heat. So, when you look at solar radiation, it consists of different waves, ultraviolet waves, visible radiation, infrared radiation, and it can be measured in terms of the energy that's coming on a per unit area of a building. So, if you look at published data and if you look at the locations, you will find that the amount of solar radiation that comes is more or less uniform in the upper strata, and it would change from location to location. But when you talk about daylight, you are only concerned in the visible spectrum, and the objective of a good daylight design is to only get this and not the other part, right. So, the goal of daylighting is to get into all of these without getting into the heating. That means we need to look at orientation, the form of the building, and fenestration. Fenestration means a combination of glass, view, shading, and daylight penetration. Daylighting very often, when it comes as a part of a design intent from the concept stage, is mostly passive. That means it is an intrinsic part of the thinking of the form of the building. It's based on the climate, it's based on the impact of the cooling, heating that it has, and it ensures that through proper insulation, through proper selection of glass, you're able to get only the daylight and not the heat. There are active daylight management options which include exterior devices, building integrated solar and of course solar collectors, which sometimes are added as sun tracking devices or light pipes, which are a very good idea when you're doing a retrofit, but it's not a great idea at the concept stage when you're starting off a new building unless there's no other option alternative, because these are expensive and also tend to be very limited in their use. So, this is the basic introduction to daylighting and how passive and active daylighting systems are available for us to use in the concept design. Thank you.